Hello everyone. So today we are solving another question of JEE 2017. This is on the topic of thermal properties of matter. So let's first read the question. As it said that they're given a human body which has a surface area of 1 meter square. The normal body temperature is given as 10 Kelvin more than the surrounding room temperature. Take the room temperature to be 300 Kelvin. Okay, so they're given a Stefan Boltzmann constant value. Okay, which of the following options are correct? So we have to tell which of the options are correct. So before solving this question, let me write the equation which is very necessary to solve this question. That is the power radiated. It is equal to sigma A epsilon T to the power 4 minus T naught to the power 4. This is the equation and this is the Stefan Boltzmann constant here. And if nothing is mentioned, so we will assume it as a black body and epsilon will be a value will be equal to 1. So the power radiated will be equal to sigma times A. Let's write the value only. So the power will be equal to sigma times A is 1 meter square. So T to the power 4, what will be T to the power 4? It will be nothing but the T naught plus some delta T, that is like delta T is given as 10 Kelvin to the power 4 minus T naught power 4. So this is a kind of approximation that we use here. So I'll show you how. Sigma into 1 into what is T naught plus delta T? If we take T naught to the power 4 common from both of them, okay. So what will be left is 1 plus delta T by T naught power 4 minus 1. Okay, so we know that in the binomial expression with 1 plus x to the power n, where x is very less than 1, so we can write it as equal to 1 plus nx. Similarly, if we write it, sigma into 1 into T naught power 4, 1 plus 4 times delta T by T naught minus 1. Okay, so what is here? Sigma into 1 into T naught power 4 into 4 delta T by T naught. Okay, so if we write all the values, what is sigma into T to the power 4? It is equal to 460 watt per meter square. So it is 460 here. If you multiply it with 4, and what is delta T? It is given as 10. And what will be T naught? T naught is nothing but 300 Kelvin here. Okay, if we now calculate all the questions here, so we will get something like this, another 0 by this. So we know that 45 by 3 is almost 15, so it will be nothing but 15.33 something. Now if you multiply it with 4, it will be somewhere around 60. Okay, so it will be very much near to 60 as given in our option. The amount of energy radiated, that is the amount of energy radiated in a second, is nothing but the power radiated is equal to close to 60 joules. So we can mark it as correct. Okay, now moving on to option B, the surrounding temperature reduced by small amount delta T naught. So then to maintain the same body temperature, the human being needs to radiate delta W is equal to this. Okay, so what is the power radiated? Again, let me write the equation. It is nothing but sigma A T to the power 4 T to the power 4 minus T naught to the power 4. Okay, it is the power radiated. Let's suppose there is some small change in T here, so we will differentiate it. So what will be the small power, extra power, that will the change in power that will come here, right, at dP. Okay, so what will the change in power come here? It will be dP should be equal to sigma A. If we differentiate it, to 4 sigma A into T cube into dt. If we like integrate for some time, so to find, I mean, if the dP is quite large, we can write it as delta P is equal to 4 sigma A T cube times the delta T. So this is the more power body should radiate for the to maintain its temperature. So hence our option B is also correct here, because it says the same thing, 4 sigma T naught cube and T naught, more energy. It is the change in the energy here. Okay, so to find the change, we do differentiation here. Now for the option C, the reducing the exposed surface area of the body allows humans to maintain the same body temperature while reducing the energy lost by the radiation. Okay, so we can clearly see that all the equations here are the proportional to the area. So if we reduce our surface area, so absolutely the power transferred will be getting reduced here. This is because this is also the change in power is also proportional to the area here. Hence we can write our option C is also correct here. If the body temperature rises significantly, then the peak in the spectrum of the electromagnetic radiation emitted by the would shift to longer wavelength. We know that using the Vane's displacement law, lambda m times T equal to constant. So when it says the temperature rises and the wavelength will also shift to longer wavelength, this is not possible, because if they both will increase, so how will it remain constant? If temperature is rising, so wavelength should always be like getting decreased here. Hence our option 4, the option D, we can say as incorrect here. So we have got our options as A, B and C. Also, like let me mention this, like in the answer key they have only marked option C here, because if there is something which is says close to, so close to is not like a defined quantity here, because what is close to 60? So 100 is also close to 60, 61.3 is also close to 60. So I mean the JEE didn't give it in their answer key, but it is actually correct here, because it is coming almost equal to the 60 joules here. Okay, so don't just follow the answer key. I have told you all the methods to solve this question. So be stick to your concepts here. Thank you, everyone.